This world is broken. The science is outdated, the math is incomplete, and the people are so blinded by greed that they cannot see the way forward.
Wait. You're not thinking of intervening, are you?
It has to be corrected. Knowledge is not a commodity. It has been and always will be their future. Standing in the shadows is no longer an option. We have to teach them to share freely without fear of retribution.
There is too much to teach for just one person.
I know. We will have to recruit more people who think the right way. The people who have been shunned by the mainstream. People who have the passion in their heart for the science.
How do we find all of these people then?
We create an open forum to discuss ideas and build ties. We let everyone have a voice, and we never let greed dictate our path.
What do we call it then? Oh, I got it. The Fringe think tank.
The Fringe think tank it is then. Now let's give them back their destiny and open it up to the world.
Hello, everyone. My name is Nathan, otherwise known as Old Man Builds. And today we have Joel Lagace in the building today. So, Joel, how's everything going for you?
Pretty well, pretty well. Hope everything is well with everyone here as well.
Right on. Everybody's looking forward to this. Can you see the chat on the right?
I see private chat.
Click the comments button.
Oh, there we go. So I guess join the chat, right?
Yeah, so you can watch all the comments in there and everything. You can already see people that are excited to see you on here.
It says I need to connect my YouTube. Do I really have to? Because
Oh, you don't have to do anything else. I just want to make sure you're aware it's there.
okay, I see it. Yeah, because I can't chat back because I don't have my YouTube account associated on this computer. So, yeah, so it's asking me to, and I don't want to knock my. It's going to ask for verification and all that. And
Don't even worry
I
about
want
it.
to do that live.
I'll put them up for you.
Yeah.
I'll put them right on the screen. So, yeah, everybody's been waiting for you to come on. So,
Awesome.
what do you've been working on that microwave lately? You want to let us know what's going on there?
What's going on there? Yeah. Just some interesting ideas with trying to get some interesting nonlinear responses from the magnetron here. And I did a bit of research, and there is a possibility at certain frequencies and voltage, very high voltages, very similar to when you try and create X-rays. It's a cold cathode reaction. And so it would be more efficient in a way that you wouldn't need the heater, but it's to try and figure out the dynamics to that. And basically, I take advantage of the resonance chamber of the microwave, because why reinvent the wheel if it's already done for you?
Yeah, I agree.
So I've got basically Wi-Fi antenna in here, which is 2.4 gigahertz, which happens to be very close to the microwave frequency.
Oh, yeah.
And I've got a, this is coaxial, so there's a shield here, which goes into my Hack RF, which is a spectrum analyzer, which goes all the way up to 6 gigahertz. So as I feed various frequencies, waveforms, and voltages to the magnetron, I'm able to monitor for some interesting wave interactions with the microwaves. So at this point, I'm just trying to, as I've explained in some of my videos, seeing if I could at least get some microwaves to generate. And what frequency, because it might actually see when you run the heater in its traditional sense, which takes a lot of power, and the microwave transformer at 1,000 volts, let's say, at high current, this is very narrow frequency. It's almost like a laser beam. But those dynamics, because of the nonlinear nature, might change at extremely high voltages. So I have to be mindful that if there is going to be radiant energy output, it may not be at 2.4 gigahertz. So I got to sweep a wide range of frequencies at a time and see if there are any reactions. And if there are, what frequencies are the sweet spots? And from there, build a kind of resonant LC tank circuit and figure out a feedback mechanism. And my goal is to see someday maybe the ambient would be enough if it's just pure potential to drive this sort of thing. And whatever we can do with the microwave energy, do that. I'm not there yet, but as I was saying, if we can get an energy almost for free out of the environment, try and use that in its native form if we can. But being microwave too opens up the possibility to a lot because the frequency is much denser at 2.4 gigahertz. The higher the frequency, the denser the energy, and the smaller the resonant cavities become. So
Okay.
let's say you need a really big Tesla coil to get those sparks. Well, with a microwave, you can get those sparks with the equivalent of maybe this little bulb here. So imagine having like 100 of those in the microwave cavity, kind of working as when Tesla had all his multiple coils in his room, one amplifying off the other and creating a resonant feedback that kept amplifying on itself. You could simulate that with the microwaves, but within an area of a few inches.
Yes.
Much more dense and controlled and focused energy. So essentially trying to experiment with all of Tesla's concepts, but into the microwave frequencies and even terahertz later on, which offers a much denser, which means if we're trying to generate scalar waves and that sort of thing to interact with the 0-point field, those very brief openings, very sudden, sharp, with the 0-point field, there's more at high frequency naturally. So more potential in a second to interact with the vacuum is what I'm getting at. So we can collect more energy into that sort of thing as well. So that's what I'm trying to do, basically. That's where I'm at.
I have a question for you on the resonance chamber inside the magnetron of the microwave.
Yes.
You were saying that you can get different frequencies out of that at some point?
At some point, yes, because what happened is, in its traditional sense, they're operating it as a linear device. But because the magnetron is very similar to a vacuum tube as far as dynamics, but the difference is it's essentially it's in the name. It's a magnet with a coil, but built like around a vacuum tube. There's a heater in there, so there's like a light bulb kind of an element, and basically the first half of the tube is enclosed and the other one is open. That's what's unique, is the other half is exposed to the air, and there's resonant plates. So when the electrons pass by, those resonant plates output, so it converts the electron momentum into actual microwave energy. So in its linear operation, it's a very tight frequency. But when you start operating in its non-linear range, then that could very well change, like when we introduce spark gaps to Tesla coils, that very non-linear effect, which is essentially what we're looking for when we're trying to tap into over unity systems.
Absolutely.
So this is a way to initiate the conditions potentially with the magnetron. So I'm not sure if it can be done, or maybe the new ones have something to stop that. Maybe older magnetrons will work. So there's a lot of work to do here in experimenting with different microwaves from different eras.
Yeah.
Basically, to figure it until you find the one that will exhibit some interesting behaviors. And when it does, that could change, the dynamics of my research anyways, because it's basically taking the Don Smith kind of stuff, but into the microwave range, which would only mean much more efficiency, much more power. So if Don Smith was getting like kilowatts, this could be a small power plant in the microwave frequencies. So the potentials are crazy if it can be. And according to the Maxwell equations and the new formulas and solutions that I've been working on, it suggests that the maximum interaction is in the microwave and terahertz band.
Really?
Yes, and the math supports that. So
that's really cool. So let me see. I have a question now. I've seen a lot of microwave experiments, and I've done a few. And rotation seems to be some of the answer if you're looking for any time of plasma discharge or anything like that. I would imagine you're just looking for some of the effects that are in there and not so much the plasma.
Yeah, not so much about plasma or anything like that, but what I'm trying to do is basically convert the ambient potential into another form of energy and microwaves or some high terahertz band and use that. So basically trying to use nature to build its own version of a jewel thief and bring the potential up at microwaves and then use that energy. And like I said, it's kind of like, taking the snowball and trying to push it downhill instead of uphill. I know a lot of people have used that saying, but what happens with the microwave is the resonant point, is basically at 2.4 gigahertz. It's millimeters for a resonant plate. So you could use something like, it's very, very, like, you could really take advantage of the nonlinear properties of everything. Like, you could introduce a tunnel diode. Those are high frequency microwave. Those can rectify the microwave energy back to DC and charge capacitors. And then you can discharge your capacitors and get real energy back out of it. So here's a way to convert that natural potential back to traditional energy that we use in electrical circuits.
So would you propose putting the wire directly on the output of the magnetron then, or in the chamber?
No, you want to have a resonant chamber with resonant cavities so that they simulate what Tesla was doing when he had multiple coils in the room being driven by one transmitter, which in this sense would be the magnetron shooting in the resonant chamber. The resonant chamber would be Tesla, the equivalent of Tesla's workshop, with all the Tesla coils positioned all around there inside the microwave. And then maybe a special plate or something halfway up there with a series of tunnel diodes with resonant loops, which would be like this. I don't know if you would see it here, but you could use this ring as a resonant loop for 2.4 gigahertz and connect it to a tunnel diode, and that's your LC circuit, which could charge capacitors.
Okay.
Poofy. Sorry, but busy. Yeah. I'm Poofy. So she's hearing me talking, and now she wants to be part of the show. No, Poofy.
That's great.
No. Poofy. Sorry about that. There we go. Be good. Okay. Yeah. Sorry about that.
Yeah.
Spontaneous.
Not a problem. So I'm just looking at it. So we want the resonance chamber. So you said like a flat plate. Is that your pickup inside there for the microwave?
There's multiple possibilities, but a flat plate, a small loop, Wi-Fi antennas connected to tunnel diodes could rectify the microwave energy. So basically, I'm trying to figure out a gimmick using pure potential, mostly the ambient, drive the magnetron, get a resonant feedback effect going in the microwave, use that to feed LC circuits connected to tunnel diodes, which rectify that back to DC energy, which can charge capacitors, and basically cap dump. That could be analog with SCRs, self-triggered at a certain range. Then you get your discharge. I really don't know what the end game is. Sometimes that's just what I do. I start experimenting like this, and whatever I find is what I find, I don't have any, because this is just a hypothesis, I can't guarantee this is what's going to happen. But it's something to try, because I've noticed that if you do the research on it, not a lot of people are taking it at this level, like trying to bring the Tesla stuff into the microwaves. And then once I can figure that out, then start introducing the Tom Bearden concepts of his phase conjugate time reversed frequency mixing for amplification. So yeah, there's a lot to try for sure. Bringing it up in the microwave. And it might be applicable for anti-gravity. It might be more efficient as well because it's a denser form of energy.
That was funny because Todd was talking about that yesterday when he presented his paper on how to work on like anti-gravity or something like that. He was talking about taking the frequency that you're looking at right there, the microwave frequency, and then hitting it with a factor of, was it to the 10th power on there? And then he had a real short frequency band of 327 hertz that would change it from regular energy to the energy it would take to lift. So, yeah, so his paper, you may want to check that out a little bit. It kind of coincides with what you're thinking right there with the math.
Right. Yeah, for sure. So,
Hey, Ben.
Hey, how's it going, everybody?
Sorry, Joel.
No, I heard somebody come in there saying hello, so I'm just
No, it's okay.
to interrupt here.
No. Ben came in, just gonna hang out with us and talk a little bit. So
no problem.
Let's talk a little bit about that the peg cell as well. I was particularly interested the one with the ice cube trays. Okay.
The ice cube trays, that one is somewhere. Probably in the storage room. Yeah, that was the one I used to run motors and a few things, I believe. LEDs. Yeah. But it was only a couple milliamps. So, as I've said before, the peg cell is not really, unless you have like 1,000 of them, something you'd want to use for traditional current. But instead, it has all these interesting features that it could be used for something as a semiconductor to exploit those features, like its electrostatic potential, its polarity inversion and flipping abilities, its electric-like properties, its self-capacitive properties. It's got a whole, I've explored a lot of them and documented as much as I could, but they do all kinds of what I would consider wacky things that could be very useful as part of a circuit for something else. So, I think it's much better to exploit them for what everything else they can do, but not so much. It's interesting to see that they'll run a clock and everything, but I think they can do much better than that for other things.
It was the battery to the peg cell, and you had an open circuit.
Yeah.
And then you were explaining that open circuit. That's the one I was really interested in.
Yeah, he was even able to take, I believe, 2 of these and put a capacitor in between, and they would self-oscillate back and forth. And I think I had that on the scope at some point.
Yeah.
Yeah. This one I just took out. You were with me there. I found it randomly. I'm just gonna see if it still has. I'm curious. Because it's basically in a couple months it'll be a year old. So
nice.
And it's been in storage for a while, so I'm just curious here if it still puts anything out. Hard as a rock, so it's dried by now. Huh, that's something. 0.5. I don't know if I can somehow show the meter here. Hold the meter. The carbon's easy to get into because you can just poke it in there. You see that?
Oh, you got 0.62.
0.62. Yeah, and as I hold it, it seems to be.
Oh, it's growing, Joel.
Growing, yeah. As it's completing the loop, it's regauging itself. That's what they do.
Huh.
They self-condition as an electret. And this is like, I haven't had anything maybe for 5 months on this. You were with me when I dug it out randomly. I didn't even know it was there. So that's pretty interesting.
Oh, it's absolutely interesting.
And that's like one of my oldest cells.
Well, what's interesting is they hold that same amount in every time.
Every time, yeah.
Oh man, that's so awesome.
And when you put a load on there, as you see, it starts on its own for no, it should work the other way around, right? When you're loading it, because even the meter loads it slightly. It's got a very high resistance value on there. So it's loading it, it's completing the loop, and then it starts to
Oh well, that's interesting. So,
it takes a load, and then it starts building up the charge.
how much power have you pushed it into it and then see how much comes out? Like, did you get to a higher amount?
I haven't. I've experimented originally with when I first baked them and they were still liquid form to condition them with like a 12-volt power supply as they cooled like an electric.
Mm-hmm.
But I didn't find any significant. I noticed an increase, but I later on realized that it wasn't hardly anything to do with the voltage, but because they can be electrodes at basically room temperature, so you only need to warm them up a little bit and they become an electret. And the thing is, because it has an electrostatic potential, as soon as you warm it up in the oven, like on keep warm for 10 minutes, it self-regauged itself and went up like 1 volt on its own once I've cooled it down after without having to do anything. So what I'm getting at is that the peg material, all you have to do is warm it up a little bit
Mm-hmm.
and then put it aside and the voltage goes up a little bit.
Oh, that's amazing.
Yeah, it's a self-charging. It does the electret effect and self-charges it with its own potential. Yeah.
So basically, when you tap it a little bit with energy, it starts to tap back.
Yeah, and I've experimented with that as well. If you pulse it, it gives you back a pulse in the negative polarity, a stronger pulse. Like it
Really?
double the amplitude in the negative. And yeah, so that's interesting as well.
Oh wow, I'm gonna have to build a couple of those because that's
But
just
you
too
have to
tempting.
remember a lot of that is the self-capacitive effect, right? So you're giving it a pulse, and then it on a scope, it drains the capacitor and shows you that dip. But I was able to measure it by so people were skeptical, so I put the capacitor between the two peg cells
Mm-hmm.
and then closed it, and then it did it. So if we were dealing with true DC here, the capacitor would block the flow, right?
Right.
But it still completed the circuit with the capacitor in the middle, which showed. But a lot of people didn't want to listen. But it debunked the idea that it's just an effect with the scope.
No, no, no.
No. I said there shouldn't be a flow here. There shouldn't be. If there's a capacitor, put a normal capacitor in between two DC batteries. You're not going to light it up unless you've got AC. AC can pass through a capacitor, but not DC.
Yeah, you're pulling like a Bedini spike in there where it just amplifies for a second and then
Yeah.
you catch it.
So it was like your peg cell produced an AC and a DC, so to speak.
Yeah, it does. And if you put the peg cell on the scope, you see all the random, up to 250 millivolts, random, very sharp fluctuations. And I thought it was just mine. And a friend went with his analyzer and found the same effects. He built his own peg cell, different area of the world in Europe, and he's getting the same thing.
You're an inspiration, Joel. I just got to say that. I've been watching your videos since you began, and
Wow.
I've replicated a lot of the circuits that you brought up. One of the most awesome ones I'm drawing out now was Bedini's reactive DC magnetic oscillator.
The driver, yeah, because reactive power supplies, not only are they very efficient, but they have the ability to do a power correction factor. So you can correct, it basically tunes your input to your load. So you get the same amount of power for much more efficiency.
Yeah. I studied your work for a reason. It has to do with the coil system that I use, because it's like hand in hand. Just you're using circuits. I'm using a coil to do the same.
Right.
Yeah.
Well, Gerald, he has a star coil, and he also
He has the UFO coil that I built, that I display and I've done tests on.
Is this what they call it? They call it the Starship coil.
Yes, but mine's slightly different. And
Oh,
the Starship coil is built on the Rodin
the
principle.
Rodin principle. Yes.
Yeah, mine looks like a Starship coil, but it's not. There's a whole separate layer system on the inside that's
Nice.
geometrical that has nothing to do with the Starship. But yours was, I was rather impressed. Good job on that.
Yeah, I'm happy that at least somebody did something good with it.
Oh yeah, well, I watch your stuff all the time, Joel. You rock. You're dead on. You're just. I love the way your mind thinks. You're not.
The problem is I don't know where that video went. I think I deleted it by accident. I don't have a backup of it.
I do.
You do? Because I can't find it.
I've copied almost all your videos.
It's one of those, and I think it's one of those when I had an out of body moment, and when that happens, I forget after the event. Like, ask me two days later. That's why I have to go right to the drawing board and as is fresh because it's like a dream, 2 days later, I forget everything I said.
That's like the Bedini circuit. You got that in the dream. So, yeah.
So I'm a little bit upset because you had mentioned it, I think, in an email or something or in a comment, and I was looking for that video, and I said, "Oh my goodness, I must have deleted it."
I'll find it in my hard drive, and I'll get Nathan to send it to you.
Awesome. Because I was trying to remember it, that exact circuit. I know I have an idea there, but I was like, why did I delete that?
Yeah, I'll definitely send it to you. I know I have it. And I'll draw it out for you, actually. The Bedini reactive circuit, I'll draw that out. But I'll step out of the conversation and let you guys talk while I'm doing that.
Oh, no problem.
Oh man, yeah, we're all good, Gerald. And continue. So, yeah, it's just so interesting how this whole thing loops out. So, you're doing the videos. Gerald's watching you do the videos. He's pulling the circuits that you're building, right?
Right.
Yeah. So
I'm no good at as you've seen, but I try my best. But it's good that he can draw them properly.
Oh, we don't ask Gerald to draw too many circles. That doesn't end well. But I usually figure them out and draw them out for everybody. So, yeah, last time he did it, we had to put a sensor on the screen for it.
Oh my goodness.
Yeah, I can draw the circuits. They just end up coming out looking like human body parts.
Yeah, I know. With me, I'm drawing light bulbs and that, and I'm looking at myself. I hope they're not going to think that's something else.
Exactly.
And it's like, oh, that's just so horrible.
Yeah, Nathan has a video. Nathan has a video that's hilarious. If you check it out after the stream, it's pretty funny.
Oh, yeah, that's bad. No, I was trying to say that your work's definitely getting out there. I've had a lot of people comment on some of the circuits that you made and how they're working with the products that you're putting together.
Right.
So they're all really excited about that.
Yeah, because that's something I keep hearing is people have success with a lot of it, and after they have success, they're able to understand them and modify and enhance. Some people have went further with it. And I've seen some videos, especially with some of the hydrogen stuff I was doing early on, with a similar idea, using a reactive power supply to do a lot of hydrogen real fast. And some people replicated that and built the whole fuel cell assembly, and they were getting like a lot of watts for milliamps of input through the hydrogen. Yeah, because there was all cap dumps, like a pipe with like 20 cap dumps on a reactive power supply. So it was taking it was like hard limited to like 40 MA, but it was driving all those like 20 cap dumps hitting the electrolyzer. So it was generating loads of hydrogen, and he had the fuel cell connected to that and converting that back to, and he was doing awesome with it, you know.
Oh man, that's totally cool.
And he said it knows Joel Lagace system, and they built it, and it's working really well.
Nice.
I think the hydrogen is a lot of fun, and it's efficient, and you could easily get, I would say, what you'd consider over unity with it, but it's totally unsafe. That's the problem, right? I mean, it's good for experimentation, but for the mainstream, you can't really get serious with it. You can't, you know, something's going to blow up. That's the problem. Honestly, but it's so efficient, you know, if you look at like the raw, because water is one of those things that don't need current. You only need like 0.8 of a volt or so of a pulse, and you'll start breaking the water molecule apart and get hydrogen and oxygen out of it.
Oh, I didn't realize it took that low of a voltage to do that.
Yeah, you didn't less than a volt.
Wow. And then you tune it like, you know, Stan Meyer had, where you have the
you could tune the whole device. Yeah,
the electricity's resonating with the electrolysis tubes, and
Yeah.
you're preconditioning the
that,
air for bubble cavitation, all those good things.
Oh yeah. So there's a lot there for someone that was into that, but
That's awesome. We have more people like building these devices, though, because that's what we need. We need more people building these devices and seeing like there's something that mainstream science can't explain with them.
Exactly.
Yeah, I love it.
It's really cool that I showed you. Know, if you want hydrogen really, really fast, you just need a little bit of magnesium powder and just stick some vinegar in there, and you get loads of hydrogen. And I did that in some experiments in a little lab, you know, in a jar, and put a little bit of I stripped, you know, like just a few pieces of magnesium in the tube, and then I put the vinegar in there and the salt, and it just bubbles right up, and the bubble is all hydrogen gas, and it'll bubble for like a little piece of magnesium will bubble for like 3-4 hours nonstop. So if you've got a fuel cell, it'll keep a motor going. Like I had it running a Bedini for like 2 hours, just out of a little piece of magnesium. It disintegrates the magnesium, obviously, because that's part of the reaction. But it's really cool if you know, you don't need to use electricity to create the hydrogen this way.
Oh man,
that's interesting.
It's a pure chemical reaction.
Bernie gonna love that.
Yeah.
If you want to have a lot of fun with it, you go to the dollar store, you buy yourself some balloons. You buy a little, you know, those little portable vinegar things, you know, for takeout vinegar. What am I looking? You know, I'm looking for the English word here. You know, like just like ketchup and vinegar for the takeout. What do you call it?
Oh yeah.
Yeah. So and a couple of flakes of magnesium powder, you put that in the balloon, you tie it up real quick, the balloon expands and expands with the hydrogen gas. It flies up, and make sure you have a field away from people. You have a little fun with it. You point a laser at there, one of those high-powered 5-watt laser. Poof.
That's so cool.
Yeah, I know, right?
Just so you know, my reputation, I love things when they explode. Right. And I love when voltage hits everything. So
yeah. So that's a lot of fun, but I mean, it has to be a controlled environment, obviously.
Oh yeah.
You know, but if you're like out in a farm field or something, you can really have a lot of fun with that, popping balloons.
Yeah.
Hey.
Hey, Mike. Mike Faraday's joining us as well.
Mike.
How's it going, guys?
Doing good. We're talking to Joel here, Mike, and he's talking about exploding balloons and stuff like that with some hydrogen.
Yeah, I've been listening. Yeah, you got to have
fun. Do that, boys and girls.
So, Joel, I got a question for you, just to clarify. Is it Joel Lagace? Or
Yeah,
is it?
yeah,
It is. Okay,
it
so
is.
it's
But in English, they have a hard time pronouncing it, so it's usually they'll say Joel, which is the most English.
yeah.
Yeah.
Yeah, I have friends with your last name, and people that can't speak French, we just call them Lagace.
Yeah, our legacy. The
Yeah.
telemarketers. I know it's a telemarketer. When they say Mr. Legacy, we're looking for Mr. Legacy.
Yeah, I've heard a lot of people call you Lagace, right?
Well, that was probably me in the beginning saying the
You're
wrong
not
name.
the only one, Nathan. There's a few people, right?
Sorry
It's
about that.
French thing. I just wanted to clarify. That's all. I'm still drawing this thing, trying to make it not look wrong.
I think I'm the closest one to Joel. I live just outside of Hamilton.
Yeah,
So
yeah. That's
yeah.
like close. It's 8-hour drive.
Yeah, 8-hour drive. Yep.
Yeah, and I'm in Manitoba, so that's like probably a
Close and relative to, I guess, everyone else that are like so spread out, right?
Yeah. Well, I got a little surprise for Joel. I just completed my full-size power cell.
Full size power.
Basically, yeah, like what you've been working on, your peg cell.
Yes, yes. So
Yeah,
you big
so
you
I made
build one.
Yeah, so I basically took over what Michael Allen Kantz was working on. He
Okay.
passed away in 2022,
Oh,
and he was working on a power cell technology. It's very similar to what you're doing, but he wasn't using PEG.
he wasn't what?
So he was using a method similar to what you're doing, but he
Okay.
wasn't using PEG.
Okay.
So right now, unfortunately, I'm under an NDA. I can show the cell, but when it comes to exactly what's inside, I can't show. But I do have a working prototype right now. They're 12-inch plates, basically, and they create a very unique redox reaction.
Hmm.
So when I'm running the cell, they can produce about 4 to 5 amps at 1.6 volts.
Nice.
Now, what's unique about the cell, if I detach the load from the cell goes to sleep. It has the
It's kind of like what the peg cell does.
exactly, and that's where you kind of triggered me to get back into it again because I was working on this about 2.5 years ago, and I always had the big problem with the magnesium deteriorating.
Right.
But lo and behold, I found a method to basically stop the oxidation process.
Hmm.
So when it oxidizes to create power, I have found a natural organic agent that
Hmm.
destroys oxidation on contact.
Right.
Thus, the magnesium will last a very, very long time because
Hmm.
of this.
Okay.
So, yeah, it's looking really promising. I'm just out here
Awesome.
having a smoke, but when I get back in, I could show you guys what I've built.
Yeah, he's got just so you know, Joel, got one probably about the size of my fist, okay, for his first one. And then
Right.
now he's got 1 foot by 1 foot plates that sit in
Yes.
the big cell
Yeah.
that he put together. So, yeah, it's pretty interesting. Like I said, it goes right in line with that peg cell. Everybody loves that thing.
Mm. Yeah. What would probably work well is actually what I found. One way of getting current out of them is making the layer as thin as possible, like a supercapacitor
Exactly.
between
Exactly.
the electrodes.
Mine are about 2 millimeters apart.
I'm sorry, Mike.
Sorry. Yeah, mine are about between 1.5 and 2 millimeters apart. That's why you get the current I'm getting.
Yeah, that's what I was saying that I've noticed with the peg cell that when they were like pretty well paper thin, that's when they started generating some pretty good current. And at one point, I had a flat cell that was charging a car 12-volt battery.
Yep.
But the thing is, I don't have the workshop setting, so what happened is I couldn't keep, at that layer, I couldn't keep the flat cell stable long enough to do extensive experiments with. Because I literally, you know, I had like elastics and I had like felt from like craft store felt to isolate each layer. And I had poured my peg material in there, just as thin of a layer as I could, and then stacked a bunch of them on there. And it was doing very, very good. But yeah, if I had a 3D printer or something and I could actually mold these cells, that seems to be, if you want to operate the peg cell for current, it seems like the distance between electrodes is a key, and the peg makes it very, very thin.
All right, so here's my cell, and it's hovering about 1.6 volts. That's the cell there.
Mm-hmm.
So I got a big can so you can see the size.
Right.
Yeah, it's a very interesting reaction that goes on inside. Now, if I put my hand on the cell, I don't know if it'll work right now. I got the plastic side up. I have to flip it over, but I also found too, if you put your hand on the cell, there's a thermal reaction that happens that actually will increase the voltage of the cell.
Yeah.
So that's it. Now I got to make about 30 of these.
No, only 30?
Probably a lot more than that, but the graphite I have is extremely expensive.
Awesome, Midas.
Yeah.
Yeah, that's
Yeah,
cool.
it's exactly kind of like the flat design. I had much smaller, but it was kind of like that with the peg cell. That
Well, here's how thin it is.
but I lacked the ability to squish it all, you know.
Mhm.
But that's a big one to be, if that's what you're looking for. So I was focused instead with experimenting with like their electrode properties and everything else.
Yeah. It's
Because
the rebound.
I have these cupcakes as my molding.
Yeah.
So, you know,
I've seen it. I've seen every single video you did.
you know. But this has an advantage. Works great for high voltages because they're far away enough that they don't arc.
Yeah.
So it had some interesting effects with high voltages.
Hey, Joel, how pliable is that material when you first make it, when you first mix it?
It's like a paste. Like
So
it almost looks like the stuff you would the glue for your wallpaper, basically. You remember when the wallpaper paste?
Yeah.
What it ends up looking like.
Wow.
Yeah, or like toothpaste, when it's starting to dry.
Yeah, and then it starts to, then it eventually gets hard as a rock almost. Well, you know, it'll break easily, but really hard, you know.
So if you built a mold for it, can you inject it with like a cake bag or something and get it?
Well, for my pipe ones, what I did is I had a syringe, and I actually, when in its hot state, just poured it with the syringe in there.
Oh, very nice.
Yeah.
I didn't know that.
Let it cool off like that. Because like John Hutchinson was doing with the pipe, you're able to get that very narrow in between the two electrodes. So I couldn't just pour it in there with a mug or anything. So I went with a syringe and manually put it in there.
I asked because like Sean does a lot of stuff in the vacuum chamber, and he always makes these molds and then pours the stuff into the mold, right?
Right.
So it would seem it'd be easy if it's the same, viscosity, that we could do that with the 3D printed material and get it to hold to whatever shape you'd want.
Yeah.
Yeah, like with my 3D printer, I have a carbon graphite filament. So you could actually 3D print batteries if you wanted to. Actually, that's one of my side projects to actually make a 3D printable type cell.
That's cool. Gerald, what's going on? Did you finish your thing?
Yeah, and it doesn't look like a human.
Like I said, like I was talking to you when we were on the off stage there before going live. I'm a bit sidetracked because my high voltage module I think is going on the bump, so I'm going to have to build a new one just before I can do more tests with this. Because it's just that, well, you know, I've had it for several years now, and it went through a lot of experiments, so it was bound to burn out one day. But there's not much on here. I could probably fix it. It's probably the transistor is a little tired. It's right here. Transistor's mounted right here on the heatsink. Could probably change that. Yeah, I was going to experiment a little bit with the microwave stuff. Well, I started. Had the whole spectrum analyzer and everything set up in there. And then now I'm trying to figure out what I'm going to use to drive it with. That's where I'm at right now.
So
just to test it, just to figure out what can be done and what can't be. And once I get an idea, then see if I can use the ambient to drive it.
Very
so
cool.
Joel, your sorry, I didn't mean to interrupt, Nathan. Go ahead.
No, you go ahead, Gerald.
Your Bedini's reactive DC magnetic oscillator.
Right.
This is the original,
Right.
and I've tried it and it worked and it was great.
Right.
But then I modified it to my coil system and tried it, and it blew my mind.
Oh my goodness.
So you definitely have something there.
Awesome.
Absolutely. Yeah. So that's the original circuit that you created. And then this one, it's different because my coil's circular, of course. And I just wanted to show it in that sense. But yeah. Awesome job, Joel.
Nice.
And I will find you that video.
Yeah, it's funny because I'm looking at that and I have no memory of it.
Yeah,
and that's like I said, a lot of times I get these ideas and I have to just write it down real quick so I don't lose it. But but you were lucky to have found the video because I guess that was a good one. That was a good one.
I was there an hour after you put it up. You put it up at something like 5 in the morning. You had your whiteboard. You drew it out.
I drew it out. Yeah, sometimes literally after I wake up because it's like when you have a dream, you got to write it down or else you forget about it.
If I remember,
I'm there half asleep on the whiteboard, you know, kind of putting down all the info, thinking that, you know, I'll remember this forever. I wrote it down. But next thing you know,
if I remember correctly, you said you hadn't even had your coffee yet.
Oh, wow.
Yeah.
Speaking of which, that's what I got to make right now.
But I'll find it for you and we'll confirm that.
Awesome.
Yeah.
I'm glad that really works well.
You're inspiring a lot of people, Joel. I'm telling you. More than you know. People look at your videos and they take your circuits and they play with them and they see exactly what you're saying. Right. And then they modify them and turn them into other things.
Yeah, exactly. That's what I encourage. You know, this is the starting point, but you got to take it from there. And you know,
did you? Sorry to cut in. You guys see the link I sent today of Mr. Evo? He has a really good one on Tesla's free energy.
Yes, I haven't watched it yet. That's the one from 1851, I believe.
1891. His lecture from 1891. Yeah, that's a must watch. He explains it so well.
I will definitely look at that.
He's in Germany, and I think as far as like Tesla stuff, he's probably one of the top guys out there that I know of, that he knows like the real science behind it. Plus, he's an electrical engineer on top of that. So Yeah, he's pretty on the ball with this.
Yeah, he
Joel,
does.
do you watch Master Evo? Joel, do you watch Master Evo?
Master Evil? Probably not if I not. Isn't that the name of John's dog?
No. No.
Hutchinson has a dog. I think it's called Evil or something.
No. Master Evo's a long-haired guy. He
From
works
Germany.
on pancake coils, and his
Okay.
his YouTube name Master EVO.
Oh,
Yeah.
okay.
Yeah, watch him. He's really, really good. Really good.
He does some deep understanding. That's good.
Oh, nice.
He's in Germany. I think he's in Frankfurt, if I'm not mistaken.
Yeah, it could be. I'm not sure. I just know he's in Germany.
Yeah, he's reached out to me a couple of times and gave me some pointers on stuff. So yeah, when he talks to you, yeah, you listen. He's one of the best guys out there that I know of.
Oh, see, I was pretty close about John Hutchinson's dog, I guess. I'm just reading the comments right now, so.
See, the first time I talked to John Hutchison was in about 2005. So I've known him for quite a while.
He's making a new YouTube channel, isn't he?
Yeah, he's there. Interesting to say, but you know.
I think he's a new lab. That's going to be exciting. Maybe we can get Master Evo on the show as well. Maybe I'll send him an email.
Yeah, he's really good.
Hey,
And
Joel.
I had
his English is good. His English is good too. So
Okay, well, we'll have to table the Master Evo for a while.
Yeah, I was going to ask Joel about one of his circuits. Go ahead, Nathan. I'm sorry.
No. Ask him about the circuit.
I was watching your improved Bedini switch.
Yes.
And I thought that was an amazing way of looking at it. I haven't tried it yet.
Right. I'm trying building that one. People wanted to experiment, and then that's the one with the dual MOSFET switching. That's
it's a whole other way of looking at the
different concept. Yeah.
Yeah. It's almost
okay, guys.
Circuits, not just coils or anything else.
No, it's a whole different idea. Yeah.
Fill us in. What are we missing here?
So
I'm getting eager to build that one, and I want to test. I got all these different coils I want to test on it, and it might even be an efficient motor driver. You can drive maybe a motor with it, and that would be really efficient.
Do you want me to share the video, Nathan?
Yeah.
Or did you want to look it up and share it?
No, you go ahead. You know which one it is, so go ahead and put it up.
Okay. Let's see here. Present. Share screen. So there it is there.
Yeah.
Yeah.
It's just
Did you want
to because I had corrected the polarity, there was an error, and I posted the real picture. It was just the diodes were in the wrong. I don't know if I can't see it from here if I corrected it or not, but if you go to the description, scroll below to the description, go to more, and there's a form link. If you click on the form link, I corrected the circuit. It's nothing major, but it's just people, will say that it's wrong. I do.
So it was
the negative and the positive is. So if you click on that form,
my computer won't let me open it while I'm on live.
Okay, no problem. You can obviously see, where positive should be negative on the output and negative should be positive. It's just the colors are wrong.
Oh, that makes sense.
But it's the right circuit. It's just they go to the wrong. You know what I mean? Like if you follow the diode's direction, it should go the other, the plus and minus. But I
totally get it.
Yeah. So my apologies with that. I was a dopey moment and I realized, but I'm pretty sure that people know by the diode arrangements where it should go.
So your color scheme was off, not your
What's
circuit.
off? Yeah, exactly.
Yeah, that's not a big deal.
No.
But
Yeah,
awesome.
that's it.
Yeah. I want to try that circuit next.
Okay, I'll leave the link right here for the video. Somebody was asking for it. I found it.
Awesome. Yeah, if that works, that may double up even on what I'm doing because
Right.
the circuit itself is capturing back EMF.
Back the EMF, and there's no break. It's sequence. So you're creating a path that has nowhere else to go.
Yeah.
During the off time, then back into the source without affecting the MOSFETs because you're bypassing them during the off. That's what's pretty nice. It's self-isolating because it's both of them at the same time.
Yep.
So, with a typical Bedini system, if you try to put the back EMF with the diode output back to the front, the whole thing shortens out on itself. You can't do that. But this design here overcomes that issue.
That's awesome.
Without needing, isolation transformers to send it back or anything, which would introduce more loss. This is like literally direct. Poof. It just follows the path back into the input.
I'm definitely building that one because that could actually improve even
a lot. Yeah, for a lot of things. A lot of drivers for all kinds of things. Wireless coils, motors, all kinds of projects that would be good for, I believe.
I'll be right back. Excuse me.
Right on. So yeah, that's really cool. I see a lot of actual circuits on your channel now that you know what I mean. Hold on. Let me pull this up real quick. So you have some pretty long detailed circuits in here.
Yeah. Sometimes I get a little carried away.
Don't we all, huh? All right. So on that high voltage, though, you have an AC fly back there, and then you said you had a multiplier.
Right. Yeah.
So when you run your DC, do you just run a ZVS to it?
I don't have a ZVS here. So all this is a high voltage AC generator. And I fed the output to the voltage multiplier, which converts it to DC, high voltage. So essentially, if you would want to go higher voltage, you'd have to spark gap the DC output and then do another multiplier stage. Yeah.
So I have on my AC right now, I have a positive multiplier and a negative multiplier.
Yeah.
And then I have to make sure I know which ones are which, so I wrote them down on there. So if you put the negative multiplier to something, your like ion lifter or something will just suck to the table and it never will lift. So you have to switch to the positive side and then lift it. I always forget that when I'm looking at them, so I had to go back and write them down and put tape on them, figure it out, because it was the real disaster after a while.
I know. Sometimes you end up confusing yourself with your own arrows and.
Yeah.
So true.
Yeah.
You're in a hurry, so you draw the diode backward, and then
exactly like I did there with my circuit. And then people are scrutinizing me for it, saying that it's all garbage because of that obvious. But anybody realizes, it's just he mixed the colors up. Big deal.
Yeah, no big
deal. People will pick at that, right? And they scrutinize it and they say, well, you don't know what you're talking about. You can't even get it. But again, I do this. I'm just an individual. I'm not a paid professional in this field. So, you're going to have a little glitches here and there, mostly in formatting. Doesn't change the story at the end of the day, really.
Yeah.
Exactly. Just just ignore the logical fallacies. That's what I got to say. Pay attention to the science.
Yeah. For sure.
Awesome. It's good to have you on, Joel. I haven't seen you on too many podcasts, so it's an honor.
Yeah, I'm. Well, generally speaking, I figure not a lot of people are into this stuff very much.
There's more than you think. There's quite a community that's gotten together and is working
Good,
on this.
they're just not they're not watching my videos. Maybe they're watching yours, which is a good thing. But
They're
they're not watching mine. That's for sure.
That's
They're
why we're
watching
networking.
yours.
Networking is good for that, you
Yeah,
know.
that's the thing. For
We,
sure.
we can direct our audience to different channels that they'll be interested in, you know. And like I was just talking to Joe. Joe was like worried because he started out as a fan on my channel, a subscriber to my channel, and he just resonated to Nathan. I'm like, no, that's the point of us networking. You find the channel that resonates with you, and for some people that might be multiple channels.
Yeah,
But we all offer a different perspective here, and we're trying to help each other get the message out. So I think, a coordinated effort is going to be needed for that.
But by the way, Joel, we put your page in the chat so that everybody can click on it and find you. And then we also put the link to the circuit in there. So,
all right, awesome.
Yeah, we always try to distribute the information. If somebody asks me, I'll send it to them personally. You know what I mean?
Nice. I'm just reading the chats here, catching up on the conversation a little bit here.
Well, somebody asked a question. It says, ask Joel about the chaos magnetic pendulum.
Oh, yes, that thing. Yeah, what about it?
Oh, he was just saying to ask you about it. I haven't seen that, so I don't know what it is.
Oh, it was it was trying to, it's been a while, but it was the, pendulum with a magnet with a bunch, some other people have actually done this. And it works for a few minutes, and you've got these random coils on the bottom, and when the magnet goes back and forth, it creates energy, and the light bulb can flicker around. And I had an idea of like having like a little motor or lever at the top or something to give it an asymmetrical, to keep, because after a while it settles, but for a few minutes it wiggles around, and for that moment, and you literally just had to give it a little tug, right? So my idea was just offer a system like every minute it gives it a tug or something with very little current, and during those 2 minutes where it's going in chaotic mode, rectify that into a supercapacitor, and there's your energy generator. That's all that was.
That's
and
really
people
cool.
got mad at me saying, no. And it was like, people are already doing this. People have built it. They've shown it work. And there's no hoogie boogie. It does quiet down on its own. But my point was asymmetrical regauging, like Tom Bearden says. Offer a mechanism that gives it a tug every 30 seconds just to keep it in chaotic mode. And everybody a lot of people got angry with it. Or if you look at it, the comments, they're all mostly negative. But it's like, if you guys don't want to listen, whatever. I offered an idea, and people mostly went poo-poo all over it. So, well, what can you do?
I've
Don't
been there,
stop
man.
the ideas coming, Joel. You
just
think
keep
outside.
going. And that's what
Sorry.
I do. I keep going. And
Yeah, you just can't let it get you discouraged.
No.
That's all. Because
You
people
think
are always
outside the box. That's
Yeah,
what we
and
need.
most people don't think outside the box, and that's what I have to remind myself. Like, most people don't think like we do, and that's
Right.
just it's sad, but you have to be trained really to think critically.
Right. For sure.
Yeah, so don't stop. Keep that up, because you never know what's going to be the next big thing.
Yeah, that's for sure.
Yeah, one of the most important parts that we all, I think, believe in is the more we show our work, the more we get our ideas out there.
The more we become mainstream.
Yeah, and the more
Yeah.
people get interested, and then they start experimenting, and they start seeing unique
Seeing
things.
it for themselves.
Exactly.
Right?
Lead by example. That's what I always say.
Yeah, that's what we want. That's what our goal here is, as far as I'm aware. Correct me if I'm wrong, Nathan or Ben.
No, that's our goal. Get everything out there and see what people like, and even if they don't like it, build it anyway, and then continue to build it until you perfect it, and then the non-likers will become the likers after a while, and they're just going to have to deal with it.
Yeah, and an important part of that is kind of trying to deconstruct and debunk some of the myths surrounding these devices.
Yeah, that's what I was saying earlier. There's a stigma behind all of it,
Mm.
and there's an opportunity to scam and make money with all of the, because you can make it look pretty, right? And it does nothing at all. You know,
For sure.
people got, it's true. Like for example, you know, I don't want to say the name of the popular channel, but you guys all know it. With all the big Sparks and Tesla coils, you know, like what good is that if you're not contributing with it? If it's
You're not
just
paying attention to what Tesla himself said.
you
Yeah.
know.
Yeah, no, well, I like to, and whenever I have a debate on somebody who is very skeptical, which I started out in a place of skeptical, and you know, skepticism is healthy, you know, to have in doses, you know, be an open-minded skeptic, you know, challenge things and look into them. Don't take them at face value. But when I'm challenged with debating some of the science with a hardcore skeptic, I go back to Tesla and Maxwell, you know, listen to what they said. And our technology is mostly reliant on, you know, the technology they brought us.
Of course. Yeah.
And we can't just ignore like a big portion of what they said about the ether. You know, that has to be. And then we just had a gentleman prove that the Michelson-Morley experiment was done wrong, and done correctly. We do get that drift pattern that shows the ether. So those two combinations, I think we're starting to have the evidence, you know, to kind of destigmatize the topic a little bit.
And I'm noticing, you know, it started with Tom Bearden and a few people in that time. And Tom Bearden was very, very good in the beginning. But between me and you, I think in his later days, he became compromised.
He did.
Yeah.
Everything went in another direction.
Regardless, you're right. He inspired. Yeah.
But he inspired a lot. So I give him a lot of credit because what he does put out is the stuff, you know, what is right on is right on. You know what I'm saying?
Yeah, and he inspired a lot of the people that we're seeing that have looked into, you know, their theories and developed some of the Bedini technology. Exactly. You know, that it's because of the inspirations that, you know, were drawn from, you know, Bearden and Floyd Sweet, and Eugene Malov. You know, these people were like, you know, let's look into what they had to say. And now we have a whole generation of people, you know,
that's had it,
exactly. And you know, we have knowledge to gain from these people.
For sure, yeah.
People like Nathan and Gerald. Yeah, you guys.
Well, Bearden was a genius in the sense that he could look at something, pull it apart, understand it, and explain it to the common man, right? Kind of like what Nathan does and what others do, you know what I mean?
But there's issues, you know, that like I said, especially I think he started getting a little bit deceptive when he put out his mag circuit, because he talked about all the mechanisms to do it before, but once he actually built it and publicized it, everything was like different than what he previously talked about to achieve those very conditions in his design. For example, he talks of ferroelectric materials, magnostrictive materials, barium ferrite, and building cores with that sort of thing. But then he leaves it all out when it comes to his mag design, and people wonder that try to replicate it, why it doesn't quite work as it should. But if you listen to all the hints he left in the past, you are able to build the mag and make it work as it should. It's just he left out a few details.
Good job, if it was a patent, sometimes people, like inventors, will leave out key details for various reasons. I know sometimes, like if you're working on a free energy device, you literally can't say, you know, that in the patent. You have right. I've known inventors who have had patents that they specifically exchanged parts and components just to make it look like it was, you know, not fringe science.
Yeah, exactly. That was an issue with Bedini when he put up his Bedini circuit. But the thing is, I'm really surprised that the patent office gave him the patent, because he copied it from the Adams motor, which was patented before he was. If you look at the patent of the Adams motor, it's exactly everything the Bedini motor is, except Bedini added for charging batteries at the end of everything that the Adams motor was.
Was the circuit
what's really weird is the Adams motor expired, but once it expires, it becomes public domain. So how did Bedini get the full cover of that patent when it wasn't really his invention? All he did is, oh, well, I'm taking the back EMF or inductive kickback, whatever you want to call it, and charging batteries with it. So he had that additional stage, which was basically a diode charging a battery. But everything else was the Adams motor. The exact diagram, the exact same schematic. I think he even cropped the same wheel pattern out of his original Adams motor patent.
And it was
weird.
I didn't know that.
And he turned around and basically took full credit for that. Which
the same circuit.
He did good in his ways, especially with the Ferris wheel design, which was based with the hub motor, which was an additional system he doesn't talk much about, but it had barium ferrite in there. And that was why that specific system worked as it worked. But he didn't get into much. That wasn't a traditional Bedini like the Adams motor, which he presented like in the vacuum series with the big Ferris wheel. That was completely something else.
Yeah. Was it the same circuit?
Sometimes don't know, and they figured that it's a regular bike wheel Bedini, but times 10, in dimensions. But it shares similar mechanisms, but it's not the same device at all.
It was 13 feet, wasn't it, in diameter?
Like that. And it had trigger coils and one pickup coil, and it had the hub motor in the middle, which was based off of the NASA design. And he replaced the magnets with barium ferrite, so it gave it a kickback. So that kept the thing going. But he doesn't talk much about it.
What was the name of the inventor for the motor?
The hub motor, it's called. Hub
motor?
And it was a NASA thing.
And what was what was the other one you mentioned earlier, the guy's name?
It's a very efficient motor.
The Adams motor is the same motor that Mike based his work on.
Right. And that's the Bedini. That's the original, essentially the Bedini bike wheel. The first Bedini.
You know what?
If you look at the Bedini, the one he patented, it's the same as the Adams motor.
You're the first one to make that connection, Joel.
It's
I love it.
The same, and he took full credit for it.
Wow, because Mike
it's weird that the patent office granted it because it was public domain.
We do see a pattern of that. These devices are older than we think.
Yeah, exactly.
See, Mike Faraday, the guy that was just on, he built the motor that's an Adams motor, and he's doing awesome with it. And me and him have discussed how close it is to my work, which is based on Bedini's.
Yeah.
So basically, it's based on the Adams. That's mind-blowing. I love it. Thank you, Joel. I'm going to have to look at the Adams motor a little deeper now.
Maybe Bedini was a student of Adams or worked with him.
Maybe he knew something. Because the only change he did, if you look, you can still download the original Adams motor patent that got registered and approved, and you could download the original patent from Bedini, which is also expired now, but was approved. And you compare the two side by side. The only difference Bedini's has is he uses the inductive kickback with the diode to charge a battery. The original Adams motor doesn't have that extra component. That's it. The whole mechanics of the wheel and the timing.
It's probably just enough.
The north polarity on all the magnets.
Exactly the same. Yeah, it's probably just enough to get the patent looked at or whatever.
So Bedini used to hang out with that CIA guy. I wonder if he got that whole system out of that book and was waiting for the patent to literally cancel.
And
so he
could be.
That's mind-blowing.
Yeah.
So that means that those books that he had might actually have a lot more of those free energy devices that have been shelved throughout time.
Yeah.
By the way, did you guys?
I've actually mailed. Well, not mailed, but back before he blocked me, Richard, his friend that was working with him, he's got a channel too for the energy stuff. And I asked him because I had all of the from the vacuum series, the DVD with all of the Kiska files, his.
Oh yeah.
And I said, there's a lot in there, but from the series, he has a moment in the vacuum DVDs where it's all laying on the table and there's like boxes stacked on top of boxes on top of boxes, and these binders and binders. And I wrote the message to Rick, are you sure you guys like scanned everything? It seems like as much as there's in there, I think there's something missing. And he got all defensive in his comment, in his public comment. We spent 2 weeks scanning all of the documents on the machine by hand, and it was a lot of, he got all defensive with it instead of. I was just curious, was there a box or something that didn't get? But yeah, that was his answer. Yeah.
Who was that?
Rick
That was
Fringe.
Rick. That's it. Yeah.
But by the way, I just want to tell you guys, Bedini was an excellent reverse engineer.
Yes.
He knew how to build. No, he did. He built
maybe
everything.
That's how he got his system.
Yeah. Oh yeah. No. There's no question about it. Bedini was a reverse engineer, and he took multiple systems over multiple platforms and built every single one of them.
Makes you wonder if he was working with that guy rather than that guy was just having fun with John Bedini. You know what I mean by that? That agent that he always talked about, Sir.
That John. Yeah. And I did a search in these gut roots because I was really bored one night and I started trying to search his family and everything. And I got to roots from an institution in Russia, a learning institution in Russia that he had ties to, this John Seska guy. And then I started looking into his brother, and I was doing very good with finding out what his brother was into. And then he unfortunately passed away a few years ago. So his social media accounts went. But up then, there was a lot of, like I said, it was something, I think there was a tie to a Russian research facility with that John guy that was hanging around with Bedini.
Yeah, Sir John.
It makes sense because they're really hot in the scalar waves and all of that. That all the extended Maxwell stuff, they were well into it before North America was like even under the hood. Russians had a leg up on that kind of stuff.
Big time. Bob Grenier, he talks about it, and he's been traveling to Russia since he was a kid.
Yeah.
And apparently they have books.
There's a lot of it I have here that I still one day, if I have the time, I have to translate it all. It's easier now with the computer and AI and everything, but you still got to run it page by page and translate it. And sometimes, there's limits depending on the services, then you have to pay for it. And I don't want to start paying hundreds of dollars just to translate stuff for, just for myself.
Yeah.
So it takes a while to pull the information down, but they have a lot. Pretty well everything we talk about, they pretty well decoded all of that Maxwell stuff years ago in their own ways. Yeah.
Yeah, I've said this to Nathan before. All this tech, everything we're working on, it's nothing new under the sun, but we're rediscovering it.
Yes,
and it's new to us.
It's hidden from the mainstream. And if the mainstream can find it on their own and share it with regular people, like you say, and others experiment, then it's not such a secret anymore. So who cares if they don't want to talk about it, and half of the people know anyways. We'll do it ourselves, right?
Absolutely.
Well, some of the stuff is hidden in what they put in their ancient art, mandalas, stuff like that. And you actually have to pull it out and put it into an electrical form to really understand it. So the secrets that they thought were hidden forever went away as soon as somebody started to wind wire. They knew it was over.
Yeah.
Yeah.
Just a matter of time.
Just look at the dream catchers,
Yeah, it's been passed down for centuries.
Yeah.
Absolutely.
Because basically that works on the principles, I believe, of dielectric resonance.
Yep.
The opposite of you know what I'm talking about. Because of the brain frequencies and the scalar waves that could interact with resonant dielectrics.
Yep, Absolutely. I can show resonant waves in ice that, and I was talking about this on a previous live. I took a coil, I put it in a container of water, and I had the wire come out of the freezer, and I put it in the freezer, and I was freezing it as I was pulsing it.
Right.
And then the wire came off the coil, but the lines still showed up in the ice.
Nice.
Yeah. So we're there. We're there.
To try, I haven't done this yet because I'm also a ham radio, but not too much for ham radio contacts, but the technical, all of the background of it, the technology aspect and the home brewing and all that sort of thing, which most of them don't do anymore. But that's what I'm interested in. I always wanted to build like a loop antenna and just fill it with water. And then measure the resistance and build an LCR loop, taking the self-resistance of the water and the inductive of the, and use the water in the pipe around the plastic as the actual antenna at resonance and see how it would behave,
Well, I can tell you this. I'm now at the point where I'm using water as a ground line.
Yeah, a water antenna. Why not?
Yeah. Yeah. So Tesla's
the issue with water is it's got resistive. It's resistive, right? But if you're building an LCR circuit, you need that resistance to form your resonance. Mm-hmm. So at a certain frequency, that will be to your advantage.
You're smart, Joel. You know what you're talking about, man. I'm telling you, that's awesome. Thinking outside the box brought you a point where you actually understand this tech probably better than most. Good for you, man.
Maybe just because I live in the bush, nothing else to do. Keeps me out of trouble, and helps, the betterment of the cause. Everybody who's sane anyways wants a better world.
Yeah. Exactly.
You know what they say, idle hands are the devil's playground.
Yeah.
Yeah, so true. I want a better world for the next generation. It's not looking so good for them right now.
Not good at all, no.
Mm-hmm. Yeah. Me, I've had a life. You know what I mean? So whatever this tech does, it's for basically the future. Yeah. And I hope they take it and use it.
For sure. So how long do you guys usually carry this out? We've been like an hour and 20 now. So you just keep talking until whenever you're
just scratching the surface, Joel.
We talk until one of us passes out.
Yeah, or until you're tired.
Not that bad.
Yeah, that's
no. Look, we're usually around 2 hours, and then you know what I mean. If everybody's done, we're done.
Right.
So that's usually where we are. So yeah.
Yeah.
Oh my goodness, buddy, he's having as much problems with his background than I am. I hate that. When I put the green screen thing, it never works right.
Oh yeah.
You get that blaring too all the time, and I haven't been using it lately because it gets I don't know. Maybe because
it's not very accurate with this.
Yeah, maybe it's because I need like the real green thing behind me, and then it would work.
Yeah, green screen is always recommended. You don't get the flickering.
Sure. Yeah, because that's what. Yeah, I get the same problem with mine.
Mm-hmm. What it's doing is it's using some kind of AI algorithm
to try and
remove
it out. Yeah.
And then it's smoothing out the edges and distorting the edges too.
Yeah.
I went and got
I use it once in a while, but people like the audacity of seeing the mess behind me, so what the heck?
That's not a mess, buddy. That's not a mess.
I actually have to disable it because I wanted to show you guys what came in the mail today from Michael Morell. A package with a lot of love. He gave me a lot of coil frames, and this is the version 3 advanced 432 coil frame he reverse engineered from First Stop Energies. And as you can see, he's already wired it with string to give me an idea of what it should look like. We're not exactly sure how 100% sure how it's wound, but we're like confident this might be the route. And what it is, it's utilizing 3 channels. Here, I'll show you if I can. So you start out in the middle like you normally would, but instead of going over and up 1, you go over and up 3, and you leave a kind of extra 2 extra spaces for the other 2 channels. And what I'm going to be doing is I'm going to be trying 6 wires each channel. No, I'm sorry, 9 channels or 9 wires each channel. So we're gonna try laying 6 to 9 on top of these, but we're gonna layer them and see what kind of effects we get, specifically with energy and the neodymium sphere.
Are you crossing each layer or just running one then the next?
So just one, then the next. So it's not like the bundle where you do it all at once. What we're going to be doing is laying them individually on top of one another. So I'll, measure out ahead of time, 9 wires, and then I'll lay them. They're not going to be connected. I'll lay them. I'll put them on individually, and then
Okay. But what I'm saying is, you complete one full pattern with 1 wires or the 3 wires, then you start the next pattern.
Yes. So you complete one pattern and then do the interference pattern for that same, and then you start the next one. You go up 1,
Okay.
and you continue. Yeah. So it's a little bit different than the bundle design that we did for the our coils. And again, we're going off of very little information, trying to reverse engineer this thing. So it might take some time to get, but this is a nice start.
That's a lot of winding.
They're so much different than mine. Like, even if I know how I made that UFO coil looks like a Starship coil, but the principle's so different. Yeah.
And again, it's all about the geometry. The geometry that the pattern's going to make in that electromagnetic field. So with this one, it's more. I'm sorry.
I apologize. Go ahead.
No, you're okay. With this one, it's more attention focus. It's more directional, right? Whereas the bundle, the multifiler, is kind of like we're gonna randomly twist these up and wire it around. This is delicately placing the wires individually on top of one another, so they form this perfect cross pattern, right? And it's all about the spacing. Yeah.
How many slots are in those discs?
God, I haven't counted them.
Never mind then, because it'll take.
That's a lot.
Yeah,
it does look like a lot. I need to ask. There's got to be at least 32. I'm assuming 32 spokes.
That's a 32-point coil then.
Yeah. So somehow it adds up to 432 in some way. The numbers, whether it's 3 channels and having, I'm not really sure, but somehow this relates to 432 because this is their 432 coil. And that's basically all the information we have to go on. So if anybody has any information that they remember from, First Stop Energies and their videos, please contact me at beneficencetv@gmail.com. But yeah, he sent me a whole mess of coil frames. We got like 5 other ones to mess with too.
You should take a picture of that bin, put it on those Facebook groups, and see if they have it, because they'll probably know exactly how the winding went.
You're right, exactly. Because if anybody has if anybody's probably in the related in those circles, it's going to be them.
Yep.
And next time,
that's a good idea.
Do with a bit of a deeper voice, Ben. And if anyone has information, please contact me.
I'll put it on a milk carton.
There you go. I love it.
So bad.
Gotta have fun.
Oh, that's funny. That's funny. But yeah, no, we got a whole bunch of coil frames to mess with that'll keep us busy for a while.
Nice.
Yeah, I've got a few here as well, but I've never got to the winding process yet. But I've got a bunch of 3D printouts for different rodent coils and that sort of thing. But I shake a lot when it gets to like really precise things like that, and I swear a lot trying to get them through the hoops.
It goes back to that saying, if you have a knot you can't untie, patience will untie it. patience will do a lot. Have you ever tried it? So, it's just teaching yourself patience and repetition, really. Like, yeah, I didn't get it the first time. That I screwed up my first 2 coils, So but yeah, if you're interested, I could show you some techniques that help with that process and help alleviate the tenacious effort.
I built my first one and I didn't wind it well enough in the beginning when you first set the wire. So every time that I went in, like you're sewing, right? It would grab everything, like
Yep.
every little notch would grab it. Oh, I had to cut it off and throw it away. My second coil, 20 minutes is all it took to wind that thing.
Nice.
That was it. Right through it, no problem.
Mine didn't take too long. I used one of those kids' plastic donuts and put pins all the way around the outside and wound it like that.
Oh,
Nice.
that's smart. I never thought
Yeah,
about
it
doing
worked.
it that way, Gerald.
It worked.
Yeah, like one of these.
Yeah, exactly that. And then I
Awesome.
put the pins all the way around the midsection around the donut, and I wired it like that.
Oh, that's
Because then you can
brilliant.
see your different spacing, and
Right. You're
And
gonna
I
have to
used-
tell me how you did that because I'm interested now.
definitely. I used pins from sewing, and they had different little colors of balls on the end, and I used 3 different colors so that you could see where you what winding had to go where.
Oh, that's brilliant. Definitely gonna have to try that.
I've
Because
played
I've
with
been, like that's the biggest problem with winding the donut ones is trying to get the wire not to move when you're winding them, and getting it, so that that just solves that. So, I mean, Nunez, they used clay. I don't think they ever went to pins. They went straight from using clay to moving on to the slide disc frame. But that's actually really great because each coil, each geometry has its own use and own purpose. I believe. You know what I mean? So
I do.
Well, just don't go black and blue. You'll be frustrated with it the whole time.
I hear you.
So, Joel, on another subject, I wanted to ask you about the, and this goes to Wardenclyffe, the research that you did. I think it was in Timmins, Ontario. I could be wrong.
Oh, Project Timmins.
Yeah, where they had that.
They had that whole setup inside a mine shaft, upside down Tesla coil. They ran it upside down. They had the reflector on the ground and the Tesla coil in the mine shaft, and they sent a signal with only like a 15% loss across the country.
Wow.
Awesome.
Coast.
So that means that Tesla was right, and they just used the bottom end.
They used the button. They ran it in literally backwards.
Yeah. So they could have, if they had done it, if they had run that down, because Tesla had both.
Now they wanted to do this. Yeah, Tesla had both. He was experimenting with both configurations.
Yeah.
And this is the guy was called what's his name? Richardson. I forget his name now. Tim Richardson. He's a engineer who specializes in even making nuclear reactors and that sort of thing. Not around here, but he's able to engineer them. So to give you the idea of the smartness he has, and he had an interest, a personal interest in Tesla's technology. And he had a contract for a power plant and a mine around here in the north, here close to Cochrane, in the north where I live. And they were in Timmins, actually, and in the outskirts, and it's isolated. So they needed like megawatts of power to the mine, but they didn't have a direct way of doing it. So this Tim Richardson reasoned that by taking the power from Timmins, because Timmins has one of the deepest mines in the world. It's a statistical fact with the gold mines. That would be a good conduit to shoot the energy to any mine because it's in the earth, right? Where they need the energy with minimal loss. So they started doing some testing of that. And then the time when Ontario Hydro, which was the big electric company of the north at the time, which had their head offices in Toronto, Canada, heard of the project and the developments of it, threatened to cut Timmins off completely of the electricity supply if they were to proceed with this project, because it would hurt because they were investing in the hydro dams in the James Bay and running the big transmission lines into the U.S. And they didn't want to screw around with that investment. So they flat out threatened the city of Timmins, we're going to cut you right off if you dare to proceed with this project.
Wow. That's amazing. I don't think that they
That
needed.
was in the late 70s.
That was in the late 70s. That makes sense.
70s.
Wow. I wonder if the equipment's still there.
I visited the site, and there's still pieces and stuff. There's wires, there's isolators, there's that graphite stuff like Tesla was experimenting with for the base stuff. A lot of it is still there. I even went a little bit into. I've got the recording on that. You saw a little bit into the mine shaft, and
Yeah, I see that.
and some connections, and yeah.
I should take a trip. It ain't that far. I should come out. That would be just awesome. Right? I would love to do something similar like that. There's another spot that could work in Thompson, Manitoba, up by the nickel mines.
Right.
They have some deep mines as well.
Okay.
But putting together a project like that might be a little difficult.
Yeah, because they had at the time they had the coordination with who was it now? It was a university, one of the big ones. I have it. I don't remember off my mind, but I have the information written down in the video. It was the U.S. military, but through a university research program. I forgot which university, but if I go back to the video, I'd get it right away. But it's listed on there. And they were the teeth behind the project, essentially. It was shadowed by a U.S. government, but they were trying to shoot the energy throughout North America like this. So the next phase, they were going to shoot energy from Timmins to the United States.
Wow.
But it never got to that because when Ontario Hydro found out, because they needed the source input, right, to shoot, and they were getting it from Ontario Hydro. When Ontario Hydro found out what they were using it for, they're like, no.
Yeah, because it bypasses their big project, right?
Because they're like, no.
Yeah.
Wow. I definitely love to visit that site and see if I could get in there.
Guy is still alive and roams in the area because he's still on various energy boards and stuff like that, in economy and green initiative boards in the area. But when I do stumble onto him, every time I mention the Tesla stuff, the guy just runs the other way.
No doubt.
Won't talk about any of it.
Probably terrifies him.
Probably, especially when I tell him exactly what he was doing and how. And then one time he actually asked me, he says, how do you know about my interest in Tesla's work? And then I told him what I was up to, and then
wow, eh?
Yeah.
Didn't want that info out.
No, he didn't.
Interesting. I wonder if the Wardenclyffe principle would work on a smaller scale. House to house, maybe.
Oh, yes, it does, for sure.
Yeah.
Different frequencies, though.
Yeah.
You gotta go, like, if you were to use, I guess microwaves would do it.
Because of the short.
2.4 gigahertz would do it. You could literally beam in that. And if you use Tom Bearden's, the thing is, there's always going to be a loss with the scalar wave, even though the scalar wave could propagate without the attenuation from mass and matter. But you still need to correct the wave, so you're going to have to offer that, like what Tom Bearden was saying, the phase conjugate reverse replica image with the wave mixing, to like you do in nonlinear optics, to restore the wave, and then it would work. So you use the microwave as a carrier, as a trigger, as a waveguide, and then fix it with the wave mixing at the source to correct the loss.
Aren't old cordless phones work on 2.4 gigahertz, or is that megahertz? No.
Some of them do 2.4 gigahertz, yeah. So does the old Wi-Fi. All the old Wi-Fi stuff is all in. So that's what I like about that is it's easy to find resonant circuits because everything that's 2.4, everything that was ever built for Wi-Fi boosters, Wi-Fi extenders, Wi-Fi antennas, it's already resonant at 2.4 gigahertz. So it saves you from having to build all those precise devices that at that frequency, just a solder blob might be enough to throw your resonance right off.
Interesting.
You buy from the factory already tuned, ready at that frequency. You know? So you don't have to reinvent the wheel for everything if you don't have to.
Yeah, no, use what you got.
It's already available
Yeah.
and does the job.
We got those cats again, huh, Gerald? They're over there messing with your stuff.
Sorry, I had to let the mother in for the kittens. She was outside, so.
Gerald took in a mother cat and how many kittens?
6.
6 kittens.
This is our kitty cameo time.
She brought the baby one just to test us to see if we were good people, I guess. I don't know. I can't get into a cat's mind. And then the next morning I woke up because I leave my basement window open for my cats to go in and out. And all of a sudden there's like 5 cats in my basement plus the mother. So I guess she decided we were safe.
Yeah. Yeah, animals are very complex emotional creatures. And, you know, a lot of time we don't give them enough credit.
Yeah, true that.
Hey, Joel, there's a question here for you. Can you explain the Bedini style circuit working Gerald drawn? And let's see, explain how you use it for bifilar setup.
I can't explain it because I don't remember it right now.
That's fair.
To be very honest, you know, why make something up that sounds smart? It was like I said, it was one of those things that like I woke up and then I just had it and I, you know, it's short-term memory effects where you get that aha and you write it down and then you forget about it like 10 minutes later. So he's gonna send me back the movie and I'll know right away. But right now it's like.
Do you have it on your site?
I don't have it. I deleted it by mistake.
Oh,
yeah, I was.
Oh, that's the one you guys were talking about. Okay.
Yeah. So once I see it again, it will all come back, obviously. But right now.
Yeah, I'll get it for you for sure. Because I was looking on it. I was looking on your site today to see if I could bring it up and talk about it. Right.
You weren't finding it, huh?
Yeah. So I'll make sure you have it though.
Awesome.
Nice.
Because that's an important one. Apparently, it works really good. So
it does.
Yeah,
I was impressed. That dream was definitely worth having.
Going on, yeah. Sometimes you underestimate them. You know, I figured, well, that's just another one of many. I guess it's not that great. But then, you know, weeks later, you realize, oh my goodness, this was right. What was I looking for, right? You know.
You're not wrong.
Sometimes it doesn't occur right away that the information is as important as it really is.
This book here, this is full of dreams and visions.
Yeah.
And before I started doing my work, like you have
to write it down right away because.
Yeah, and you think to yourself, is it really going to work? Is that something I should really do?
Something I should bother? Yeah, you don't want to like. Sometimes you don't want to make a fool of yourself by writing it down, you know?
I write them all down now. I don't discount any dreams. After what I found in my dreams of visions, no way, man. Dreams are insanely real and directly connected to your spirit. I fully believe that. Yeah. So write them all down, Joel. You never know.
No, exactly. That's what I've been doing, you know?
Yeah, that book's
later on. I'll look at it and then I'll see, okay, this movie's got 1,000 views. This one here's got 90. So I'm going to delete this one here, just regardless of the information. But then that happens to be the one that's really. But yeah, it was out of no malintent. It was sometimes I try to declutter because, you know, you end up with hundreds of videos on there and it's like, okay, find one and I'm basically saying the same thing and that's shorter. Okay, I'll delete this one because I'm saying the same thing over here. You know. But that's what happened. It got lost accidentally in the mix.
That's okay. We'll put it back up there for you.
Yeah.
Or get it to you so you can.
Yeah.
Yeah. I record most of your videos, so I think I'm missing a couple. I get a database on all the best. I have Bedini stuff. I have all of Nathan's stuff. I have Apex, yours. Yeah. I got like 6 terabytes now. Well, going on 6. Yeah. That's all for me, though. I don't really put it out, you know?
Yeah. It's just
reference.
So just so you guys know, Gerald, get me the video and we'll review it on the Wednesday show, the live, and we'll just go over it piece by piece, and that way everybody has it.
Yeah, absolutely.
Yeah, because if it's that good, you know, it deserves some attention, replicating, and that's useful. You know, it really is good for people to use it.
I think so.
Yeah,
I was impressed with it.
Yeah. I was sure at the time. I knew it was going to work. You know, I don't remember the specifics, but the reason I wrote it is because I knew, you know, this has got to be something.
That's like running the secondary back into the primary, but you're not.
It's some weird thing. I'll have to look at it.
Yeah, you're using the capacitor to change the polarity in order to run it back in.
Right.
If I understand correctly. Yeah.
I'll have to see it.
Absolutely. I'm not trying to put you on the spot, Joel.
No. I'm just being honest, you know.
That's fair. That's fair.
It's fair, you know.
But I'm gonna have to actually bail because I got turkey dinner going on right now.
Yeah, and I gotta go myself here. So yeah.
We're all good. Hey, Joel, thank you very much for coming in and doing this with us. We really appreciate it. Let's give Joel a hand, man.
Awesome. Thank you.
Thank you, Joel.
Hats off.
Thank you for having me.
See my balding head, but definitely hats
Yeah, me
off.
too. I hate mine. That's why I'm due for a shave actually. It masks. If it's all gone, you can't make a judgment, right?
Me, it's like the Red Sea splitting. And,
You're not even close, Gerald. Look at mine. Look,
yeah,
it's shining.
You know what? It's
so am I. I got a bit of a tan there too.
Yeah, who cares, right? It's just part of our personality.
It is. We all get old. We can't get away from it.
Yeah, it's life.
It is.
All right, guys. I just want to say thank you to everybody and thank you to the chat, guys. You've been great.
Thanks, guys. Thanks, chat.
Appreciate everything, guys. Have a great night.
Have a good night, everybody.